A study conducted by Peyton and Al, published by the American Journal of Neuroradiology, discusses the importance of early intervention of cerebral palsy by using diagnostic tools such as the general movement assessment and brain imaging scans to see how they individually or in combination could best predict future neurodevelopment outcomes. The authors examined the neurodevelopment of infants by comparing the brains of those who lacked fidgety movements, known as FM, which are regulated continuous patterns of motor activity, in comparison with those with normal FM. Infants who did not display nor develop this fidgety movement are susceptible to neurological deficits, including cerebral palsy. This study evaluated preterm infants with a gestational period of 31 weeks or less and a birth weight of less than 1,500 grams. Individuals with cerebral palsy often have tiny gaps or holes in the white matter in the brain, arising around 26 weeks of gestation. There is a greater brain plasticity during this 18-month period, requiring diagnostic tools that can detect disorders during this time. 3 diagnostic tools were used to evaluate the infants. The first was the general movement assessment. It was used to analyze fidgety movements that can disappear with brain agitation. The infants were categorized as either normal or aberrant. Normal infants showed continual fidgety movements, and aberrant infants had abnormal, sporadic, or no fidgety movements. The second tool used was MRI imaging. This looked at white matter signaling abnormalities and volume loss. Fractional anisotropy was used to look at the connectivity of white matter in the brain. Lastly, Bayley scales of infant and toddler development, known as BSID-3, was used to determine cognitive, language, and motor abilities of the infant at around the age of 2 years old. The final step in this study was to determine the relationship between FA, fidgety movements, and BSID-3 scores. Both groups of normal and aberrant infants did not differ in total brain, cerebellum, total white matter, or gray matter volume. But while the total volumes of white matter in both groups were the same, the aberrant FM group had smaller volumes in the corpus callosum and in the right center frontal region of the brain. Infants with aberrant fidgety movement exhibited a significantly higher incidence of white matter signal abnormalities. So, while volume was maintained, the structure and morphology of the white matter was affected. During the BSID-3 testing, 62.5% of the aberrant fidgety movement infants scored poorly in either cognitive, language, or motor outcomes. Because not all of the aberrant FM infants developed adverse neurodevelopment outcomes, the microstructure of the differentiated brain regions between the aberrant FM infants that either had adverse neurodevelopment or normal neurodevelopment were analyzed. The results showed decreased FA in the motor-associated cerebral areas and the corpus callosum, impairing both motor and cognitive outcomes. In summary, preterm infants with an aberrant fidgety movement had significant decreases in FA scores compared to fidgety movement normal infants. Aberrant fidgety movement infants were more likely to demonstrate adverse motor, language, and cognitive outcomes. Within the aberrant fidgety movement group, adverse development could be further specified through regional FA scores, and there were no differences in gray matter or cerebellar volumes. Because the aberrant fidgety movement infants had shorter gestational periods, the abnormal fidgety movement is more likely to be a result of delayed development of the white matter instead of injury to it. While the source of fidgety movement is still not clear, the study indicated that it might arise through the connection of multiple regions in the brain instead of a single tract. Agitation of these areas is what then leads to abnormalities. The study concluded by saying the general movement assessment can be used as an early diagnostic tool and that those with aberrant fidgety movements might benefit from MR imaging to predict adverse outcomes.